Hi everyone, my name is Jasmine and I'm going to discuss about three law of motion or Newton's law of motion. While most people know what Newton's law says, many people do not know what they mean or simply do not believe what they mean. The first law is called the law of inertia. An object at rest will stay at rest and an object in motion will stay in motion at constant velocity unless acted upon by an unbalanced force. The second law is called the law of acceleration. Force equals mass times acceleration. The third law is called the law of interaction. For every action, there is an equal and opposite reaction. So the first law, inertia is the tendency of an object to resist changes in its velocity, whether in motion or motionless. For example, this pumpkin will not move unless acted on by an unbalanced force. And then, unless acted upon by an unbalanced force, this golf ball would sit on the sea forever. Why then do we observe everyday objects in motion, slowing down and becoming motionless seemingly without an outside force? It is a force we sometimes cannot see, which is called friction. Objects on Earth, unlike the frictionless space in the Moon, travels through or under the influence of friction. There are four main types of friction. The first one, sliding friction, for example ice skating, rolling friction, bowling, fluid friction, air or water resistance, static friction, initial friction when I'm moving an object. For example, slide a book across a table and watch it slide to a rest position. The book comes to the rest because the presence of a force being the force of friction, which brings the book to a rest position. In the absence of a force of friction, the book would continue in motion with the same speed and direction forever, or at least to the end of the tabletop. The second law is law of acceleration. The formula F equals to m times a. Acceleration is directly proportional to the net force but inversely proportional to the mass. The net force of an object is equal to the product of its mass and acceleration, or F equals to m over a. When mass is in kilograms and acceleration is in meter per second, the unit of force is in newton. 1 newton is equal to the force required to accelerate 1 kilogram of mass at 1 meter per second. For example, how much force is needed to accelerate 1,400 kilogram car 2 meters per second? So we write the formula and fill in the given numbers and units. And then, so for the unknown, and we got 2,800 newtons. Newton's second law proves that different masses accelerate to the Earth at the same rate, but with different forces. We know that objects with different masses accelerate to the ground at the same rate. However, because of the second law, we know that they don't hit the ground with the same force. For example, this 10 kilogram object, we're going to find the acceleration. Acceleration equals to F over m. The F is F squared 98 newtons over 10 kilogram equals to 9.8 meters per second. And then this one will do the same way. A equals to F over m. A equals to 9.8 over 1. Acceleration is 9.8 meters. These are the example questions. What acceleration will result when a 12 Newton net force applied to a 3 kilogram object? So, the formula is F equals to M times 12 Newton. So the force is 12 Newton. And then the mass is 3 kilograms. So what is the acceleration? 12 equals to 3 times 8. 12 over 3 equals 8. So 4 is to 8. 4 meters per. A net force of 16 Newton causes a mass to accelerate at a rate of 5 meters per second. Determine the mass. We're using the same formula. So the F is 16 equals to the acceleration 5 meters and 8. So 16 over 5 is 8. The A is 3.2 kilograms. Short question: how much force is needed to accelerate 66 by 1 meter per second squared? So F equals to M times 8 and 66 times 1. So the force is 66 Newton. What is the force of on a 1,000 kilogram elevator that is falling freely at 9.8 meters per second? F equals to 1,000 times 9.8 meters per second. So the force is 9,800 Newton. And then the third law of interaction. For every action, there is equal but opposite reaction. According to Newton, whenever objects A and B interact with each other, they exert forces upon each other. When you sit on your chair, your body exerts a downward force on the chair, and the chair exerts an upward force on your body. There are two forces resulting from this interaction: a force on the chair and a force on your body. These two forces are called action and reaction force. So, F action equals to negative F reaction. consider the propulsion of a fish through the water. A fish uses its fin to push water backward. In turn, water reacts by pushing the fish forward, propelling the fish through the water. The size of the force on the water equals the size of the force on the fish. The direction of the force on the water backward is opposite the direction of the force on the fish forward. And then the other one is flying. Flying gracefully through the air, birds depends on Newton's third law of motion. The birds push down the air with their wings, and then the air push their wings up and gives them lift. Consider the flying motion of birds. A bird flies by use of its wings. The wings of a bird push air downward. In turn, the air reacts by pushing the bird upward. And then the size of the force on the air equals the size of the force on the bird. Direction of the force on the air downward is opposite the direction of the force on bird upward. Action-reaction force pairs make it possible for birds to fly. Other example of Newton's third law. The baseball forces the bat to the left, and then the bat forces the ball to the right. Action and reaction. Consider the motion of a car on the way to school. A car is equipped with wheels which spin backward. As the wheels spin backward, they grip the road and push the road backward. And then rocket. The reaction of a rocket, an application of the third law of motion, various fuels are burned in the engine producing hot gas. The hot gases push against the inside tube of the rocket and then spit out the bottom of the tube. As the gases move downward, the rocket moves in the opposite direction. These are a few exercises. The diagram below shows a particle acted on by a set of forces given that the particle is at rest. Find the value of P and Q. So this is P, this is Q. So we'll do the horizontal first. So P plus minus 50N. P equals to 50N. And then the vertical 5Q equals to Q plus 10 plus 3. So 5Q equals to Q plus 10 plus 150. 4Q equals to 160, so Q is equals to. Given that the particle in this diagram is moving with a constant velocity, find the value of P and Q. So we're going to find the equation. 2P plus Q equals to 25. Okay, this one is 20. The horizontal one. And the vertical, 3P minus 2Q equals to 20. Then we elimination times 2. 4P plus 2Q equals to 50. 3P minus 2Q equals to 20. Then the sum is 7P equals to 70. P equals to 10. After we find P, we can substitute to one of the equations. 2P plus Q equals to 25. 2 times 10 plus Q equals to 25. Q equals to 25 minus 20 equals to 5. Okay.